Ma'am, you can pursue the talk, ma'am.
Thank you so much, Naresh. Hi, everyone. Good afternoon, good evening, depending on where you're joining from. So my name is Stella Kanyaru. I work as an associate account manager at ANSYS. I'll be looking to share my screen. I have a few slides, so just give me a minute while I do that. Yes, just a minute. Need to figure this out. ANSYS. So to close a few things. So as Naresh said, I'll be talking about the role of simulation in engineering. So I'll try and keep my presentation short, and then we'll see if we can open it up to the floor for any questions anyone might have. So again, let me try sharing again and see if this works. Says student community. Says okay, good. I think I got it. Share. Please let me know what you see on your screen. Good. Let's put this in presentation mode. Please confirm if you can see the full screen in slideshow. Just a confirmation from someone. I hear.
Yes, ma'am, your screen is visible.
Okay. Thank you so much, Naresh. So as I said, my name is Stella Kanyaru. I'm an associate account manager working for ANSYS. I'm glad to be with you this afternoon/evening. Hopefully we can engage and share a bit more. So I'll just take you through a few slides, then we can open up the floor for discussion. So I'll start with who I am. My name is Stella, as I said. I'm a Kenyan. My background is in IT, so not really an engineer per se. I got my master's in IT from CMU, Carnegie Mellon University. A little bit about me: I love doing kitchen experiments. I believe I'm a practicing jack of all trades and a lifelong learner. So I'm very much open to learning as well as helping others learn and pick up skills. I'm currently working to become a marathon runner. So hopefully I'll be able to achieve that. I'm looking to run a marathon in March. So that's what I'm training for. So wish me all the best of luck. And then my superpower is I believe in the goodness of people. And as I said, I'm always willing to jump in and help out wherever I can. So I want to tell you a little bit about ANSYS. So who are we? ANSYS is a simulation company, and we've been doing this for about 50 years now. So we started operations in 1970. So if you can do the math, comes to about 50 years of innovation and leadership. We have about 5,200 employees worldwide, with 90 offices worldwide. We've also been classified as a good place to work. So if you're looking to join a company where you'll enjoy working and interacting with people as well as changing the world, you can pretty much consider working with us. So, as I said, we started in 1970. Our first flagship product was Fluent. And ever since, how we have been able to grow all along is through acquisitions. So, we started with a few flagship products. And then, since we realized when it comes to the physics domain, there's a lot of things to do, and we needed to offer value to our customers. We've been acquiring companies over the years, as you can see. We have about 29 strategic acquisitions. We've invested about $5 billion in those acquisitions, all in a bid to make sure that we are able to offer tools to our customers that they can use to solve the challenging engineering problems. So all we do is simulation. We are not in the CAD business. We are not in the design business. Our main focus is simulation. So, and when I say we are not in the CAD business, what that means is software is very much CAD agnostic. So you can design your card in SolidWorks or CATIA or Autodesk, and then you can ship them over to the ANSYS tools, and you can be able to now run whatever designs you are able to do. So these are also some of the partnerships that we have. We work with Autodesk closely, Microsoft, PTC, Synopsys, which has actually acquired us. We're still in the process of acquisitions, but by next year that should be done. And then it will probably be a whole new outfit. Rockwell, SAP, AWS, which I guess these are all names you all know. We work closely with universities all over the world. We have about partnerships with about 3,000 universities, and we have a wider suite of partnership, which is 350 plus technology partners. So with that brief overview about who I am and what the company is, I'll take you through what is simulation. I'll jump right into the presentation. So I know I've had a message, but I really can't see the chat. So if at all there are any questions that come up, please allow me to pick them up at the end of my presentation. So what is simulation? Simulation is a computer-based analysis of how a new product design will perform in real-life situation. So I always like to give an example of if you're designing a stool, you can pull up a design in SolidWorks, design a nice stool, and then give it nice features, but how exactly do you know it will be able to work? How do you know if someone sits on it, it won't break? How do you know if I place 3 boxes of, let's say, 10 kg on the stool, it won't be able to break? How will it function if I throw it on the wall? How do you do that traditionally? So traditionally, what you do is you design the stool and then you bring it out, get the carpenter to build it, and then now test it physically. But you realize that takes a couple of iterations and it tends to be expensive in the long run. So with simulation, you're able to subject your stool design to all these forces digitally, test it out, such a way that by the time you're coming to build a prototype, you're actually sure that this design will work. So just to show you what I mean, I'm going to play a video. We call it the Lego challenge. So what they basically did is they were doing car testing using Legos, and then what they did is they simulated it, and then they tested the reality. And as you'll see, the simulation results that they got were pretty much similar to what they got when they were doing the physical testing. And this is all in a bid to show you that simulation is basically a computer-based analysis of how a new product design will perform in real-life situations. So I'm just going to play the short video so that you can see what I mean. Sorry, just to confirm, can you hear the sound? If I can get someone to answer me.
Yes, ma'am.
Okay, awesome. Thank you. Okay, so as you can see from the video, they were trying to do a crash test between two cars and they used a Lego cars. And then what happened is they
Ma'am,
modeled the same, sorry?
sorry for interrupting. We can't able to see
Yes.
the video, ma'am.
You have not been able to see the video.
Yes, ma'am. All of participants couldn't able to see the video, ma'am.
Wow, I'm so sorry.
That's fine,
I'm
ma'am.
so sorry. I watched this. I watched this alone. Let me try sharing. Let me play it like this. Can you see it? Can you
Yes, ma'am.
see it now?
It's visible now,
Okay.
ma'am.
Okay. Sorry. Um, this is right. Okay, so hope that was visible. Let me stop sharing and reshare again. I think it might be better if I reshare my screen rather than a window. So from the video, what you could see was they created they created Lego cars and then they wanted to test the crash impact. And then they also simulated that. And then if you could see from the videos, when they actually did the actual crash test with the Legos, as well as on the simulation, it was actually similar. If you could see from the impact, how some of the parts were moving once they switched between the simulation and the actual reality, you could actually see that the simulation was able to model what exactly would happen. So that's to show you how accurate simulation can be when you're actually doing some of these things. Share audio, share tab instead. Okay, so I'll come back to that. Let me share my screen. I'll reshare once I have another video. Okay. Okay, good. Then I share this, then full screen, then this. Okay. Someone confirm you can see the slide Y simulation. Okay, good. So we've talked about what simulation is, but why carry out simulation? So when companies are doing research and development, about 75% of the costs that they have are spent in failure mode elimination. So that usually means they come up with a prototype, they design it, then they probably print it out and make it. And then after they have done it, now they spend 75 of their budget, 75 of their time trying to figure out what's wrong with the design and trying to correct the failures. So with simulation, what we're trying to do is we're trying to shift the failure mode identification left with simulation. So that means when they do the designs, they are able to analyze the different scenarios that whatever they're building will go through, and that will help them to reduce the mistakes that they make. It will help them to innovate better. And what that means is by the time they are getting to prototyping, they will have saved time, they will have saved money, and they will not be having mistakes that they are catching on when it's too late, which tends to be expensive. So the impact for that is that it reduces costs significantly. It also helps to shorten the cycle times. It helps with enhanced product performance, extended product life, and minimized risk. So what simulation does is we're reducing the time spent fixing failures that could have been avoided, and then we are shifting our energy and time to testing before we even get to production, saving us time, saving us money. So that's why simulation is important. So what are the types of simulations that are out there? The first one, which is so common, is the finite element analysis. So this is used to predict how products react to real world forces such as heat, vibration, and other physical effects. Essentially, what it does is that it breaks down a large complex problem into smaller, simpler parts called finite elements, which are then analyzed. An example is when engineers use FEA to test the strength and durability of a bridge design before construction. So, like the twin bridges, before they construct it, instead of going out there constructing it, then a car passes or two and they realize it can't hold the weight of five cars. They pass through the simulations for that, figure out, test what materials they need to use, how would that perform under stress, how would that perform under fatigue, what happens to the heat, what if there's wind, vibration caused by the wind, how would that react? And then once they have figured that all out, now get to the production. So that's finite element analysis. Next, we have CFD, which is, I guess, what this group is based on. So computational fluid dynamics involves the use of computers to simulate the flow of fluids. And fluids here, we're speaking about both liquids and gases. And they simulate that and their interactions with surfaces. So essentially, it helps with understanding and predicting fluid behavior. A case example here being use CFD to optimize the aerodynamics of an airplane design to reduce drag and improve fuel efficiency. So when a plane is launching, remember there's so much, first of all, friction and drag caused by going against the forces. So you need to figure out how to optimize the design such that it's able to reduce the drag and then also make sure it's, if there's less drag, it's also using less fuel because it's using less force to go through. So we have also multi-body dynamics. This analyzes the movement and interaction of interconnected rigid or flexible bodies under the action of force. So for example, if you're designing a suspension system in vehicles, so essentially what it does, it helps to understand the dynamic behavior of the mechanical systems. We also have thermal simulations. So what you do here is you're trying to predict how heat is transferred within and between bodies. So for example, if you're designing a motherboard, um, you're trying to figure out where will you put the microchip, where will you put the heat sink. When the motherboard is powered, how will the heat be distributed across? Which areas will have high heat, which areas will be cooled? How do you distribute that so that something doesn't overheat and blows up? So that's why you do thermal simulation. Or for example, in a plane, due to all the friction that's happening, how do you ensure that it's cooled? And then, like when the wheels are landing, from the friction on the runway, how do you ensure that the wheels don't heat up and they burst from all the friction? So, what kind of material will you use? What technologies will you use to control that? So, that's where thermal simulation comes into play. Then we have electromagnetic simulations. So these simulations analyze the behavior of electromagnetic fields and waves. So they tend to be crucial for designing and testing electrical and electronic systems. So a case example where this can be used is every mobile has an antenna. So how do you ensure that if you're in a room and there's 5 of us, everyone has a phone, everyone has a laptop, someone else has a smartwatch, someone has a car key that has that. All those are electromagnetic, they all have electromagnetic waves being that they are emitting. So how do you ensure that each of them, the antennas, they don't have interference from each other? So that's where electromagnetic simulations come into play. So I'm going to talk about ANSYS software. So based on the fact of the different simulations we've used, as ANSYS, what kind of softwares do we provide for that? Again, ANSYS is not the only software for simulation out there, but I'm a bit biased since this is who I work with. So just keep an open mind. There are other softwares out there, but what I'll show right now is the different ANSYS softwares you can use to carry out the different simulations. So starting off for early stage design, we have Discovery and we have Granta. So Discovery is what we call our own CAD tool. So it's how I like to describe it is like SolidWorks on steroids. Because with Discovery, you can do both the geometry development and you can also do simulation on top of that. And it works really well in that it gives you how would I say, immediate feedback. So like if you're designing something like this, if you put a part like this and you want to see what would happen if like there was fluid passing through that, you can do that instantaneously. So Discovery is really nice if you're trying to do something and have quick iterations. You're trying to design something, simulate what would happen in different conditions, and then get quick feedback. So Discovery is really nice. Granta is what we call our materials library. So if you're trying to design, as I said, something like wheels of an airplane, what materials do you use such that if it hits the runway, it doesn't corrode quickly? Or if a company is trying to be sustainable, what materials would they use if they wanted to like move away from plastic? So Granta has like over 1,000 materials in our library, and that allows you to figure out what you'd use for your different designs. OptiSlang is what we use for our optimization processes, so that also helps you increase to do your designs better and to also set up your systems better. So for early stage design, those are the products we offer. And then for structures, we have our flagship product, which is ANSYS Mechanical. So this is where you do all your FEA. Other than mechanical, we also have other tools which all do different things. So like for example, the crash test I showed you was LS Dyna. So LS Dyna is what car manufacturers use for crash test simulations. We have Motion, we have Sherlock, Additive Solutions. So these are all different tools within our suite that do different things, but they all fall under our structures offering. So next we have Fluids, which is of interest to the group here. So Fluid is our flagship CFD product. It's really, really powerful, and we'd like to say it's the industry's most accurate and trusted solver when it comes to fluid dynamics application. So it has a wide area of applications from flight, in-flight ice accretion on airplanes, combustion in gas turbines. We really do provide fast and reliable results. And with our new releases, Fluent now has GPU capabilities. So the simulations you can do with ANSYS Fluent are now way, way insane. Like they're really, really amazing. So on the right, as you can see, these are the other products we offer. So like for Rocky, you can do particle simulation with that. So let's say you're designing a washing machine and you want to see how the different clothes will be moving about, or the different particles. Or for example, you're in the mining industry and you're trying to sift through different materials. Let's say you're looking for gold. You can simulate how that would occur on the conveyor belt. Among Chemkin Pro, you use it for chemical simulation. So let's say you're designing explosive or something, how would that react? So we use that for the chemical reactions. So again, different tools that do different things in our offering. Then we have ANSYS for electronics. This is our core electromagnetic simulation. So you use that for any electromagnetic simulation you'd want to do. So if you're trying to solve things like temperature, cabling, vibration, challenges in design, that's what you use. So a good example here is HFSS is used for high voltage simulations. Maxwell is used for low voltage simulations. And MotoCAD, you use it mainly if you want to simulate gears and do other things. So again, different tools for different things. And as you will realize as you go on, our product offering is really covers a lot of things. So, and as I said, what we're trying to do is for all the different things that our customers would like to do, we're trying to give them a multi-physics approach such that they can easily do and achieve their goals using our products all in one. We have STK. I think this is my favorite tool, honestly. So STK offering, you use it to simulate missions to space. So you can also, if you didn't know, you can do space simulations. So if you think about it, if you want to develop a rocket and send it to space, space is an unexplored region. So how exactly do you decide these are the materials I will use? This is how the launch will be. This is how the satellite will move through. These are the different physics dimensions that will apply. Remember, we are on Earth. The forces that apply to us here possibly do not apply in space. So how do you simulate that? Because you just can't wake up, send someone today, send someone tomorrow. It's also very expensive. So simulation, as I said, helps to cut down some of those costs, and it allows people to be able to do a few things before they can actually get to that. So NASA is actually one of our biggest customers, and they use STK a lot to be able to do some of their launches in space. So optics and photonics. So if you want to design like telescopes, if you want, as you're designing autonomous cars, how is the LiDAR system able to view other cars? How is it able to, how are you able to place the sensors, the lenses, how will the illumination be? So this is our tool offerings for you to be able to do that. It's also very applicable if you're doing virtual reality because it helps you with that. So we also have our MBSC and systems. So what this does is it allows you to create an ecosystem where all the data processes are interlocked. So you can do the testing, you can do the data validation, and you can do everything all in one. So this offering tends to be very helpful for people who are doing like flight controls and they want to simulate that, people who are doing integrated systems. So let's say they're doing like the rocket launch and they want to consolidate all the data from how they do the designs for the rocket, their in-flight controls, the space launches. So these tools tends to be very efficient for that. So I wanted to show you a bit of simulation applications in terms of you've heard what simulation is, you know why simulation is important, you've seen the different tools within the ANSYS capabilities that you can use for simulation, but how do people use these tools? So how can you see what others are doing and how can that inspire you in terms of your simulation journey? So I had a couple of videos I wanted to play, but I'll need to reshare my screen for you to see, to hear video, audio. So again, apologies for this multiple sharing. Just a minute. I think I'll have to do a window to share audio, share tab instead. Okay, you let me know if you can hear the audio when I share like this. So first one I wanted to show was this. So this is an application in the consumer product, and you'd wonder what are the consumer product people doing with simulation, but there's actually an application for that as well. So I'll play the video. Let me know if you can hear the sound. So let me play and then I'll pause it to get feedback. Can you hear the voice? No? Yes? Someone unmute and give me feedback.
No, ma'am, I can't hear.
Sorry?
Your voice is not audible, ma'am.
Yeah, it is not.
It's not audible.
Yes, ma'am.
Okay. So let's give me a minute. I know how to solve this. So I'll stop sharing for now. Let me open this in my tabs. That will be easier. So just give me 1 minute. Apologies for the technical issues. Sure. So just need to open this here. This here. And then share here. Okay, I think this should solve this. Yeah, this should solve this. Okay. Close. And then let me share my screen again. This should solve that, hopefully. So simulation, share, and then screen share. It's loading. Okay, let me know if you can hear the sound now.
Mars is a global family-owned business with many much-loved brands, and the scale of.
Sorry, can you hear the voice, the sound?
Yes, ma'am. Your voice is no audible.
Okay, thank you.
Our organization, that we recognize that we have a large impact on the world. And so our purpose and our vision is to make sure that the world that we want tomorrow is driven by how we do business today. Mars has a sustainability and a generation plan. And so across that plan, we have a series of goals and ambitions to make sure that our impact on our planet is continually mitigated to be fully sustainable. We have strong ambitions making sure that our packaging is either sustainable, recyclable, compostable, or reusable, to make sure that across all of our entire packaging portfolio, we're meeting those targets.
Plastics is a really well-engineered material, but obviously there's issues with that when it comes to environment, sustainability, and so forth. It's important for us to look at new materials that are not going to be harmful to the environment. Through modeling and simulation, we can accelerate that process. The tools that ANSYS brings to bear helps us to understand that virtually before we even bring the materials in-house, set up the equipment. We can really have an idea of how we're going to have to modify the process ahead of time through the use of virtual modeling and simulation tools.
Ideally, with product and package development, the more we can shrink and reduce our overall development cycles, the better, and we believe digital is a key enabler in that space. With our relationship with ANSYS over the years, it's really been a journey of learn by doing, as well as validating capabilities that have true merit.
ANSYS bridges the gap between design and reality, where it allows us to accurately predict our complex processes. We're using simulation to model our pack design and product development. it empowers us to really optimize our process, where we are tackling our bottlenecks and also identify inefficiencies.
The software is serving us, and it's really with the right data, and you pair it with the right equations and calculations, you can create some pretty formative models that can do some amazing magic in many ways in terms of predicting outcomes before we actually see them in real life.
This holistic information allows us really to make rapid changes as well as assessment, which significantly reduces the need for physical testings, factory trials, or pilot plan experiments, and the material cost associated with this physical testing is really substantially reduced. We're exploring different paper-based materials so that we can replace the plastic wrappers for our recyclable packaging solutions.
With ANSYS, it's really about partnership, and it's partnership for the long haul. It's really about mutuality, having a collective awareness of the capabilities ANSYS brings.
Manufacturing is a very complex process that requires a lot of hardware, and to change that hardware is a big, expensive, complicated process. Because the diversity of challenges that we have across our portfolio is so great, it's really important that we're able to innovate quickly, we're able to apply different types of technologies, different types of materials, and we're able to do that in a simulated world before that we make those choices to roll them out. And of course, we need to do that in a world where sustainability is absolutely paramount.
Okay, so I hope that was audible and you are able to follow. So as you can see, what Mars is using ANSYS for is they're really trying to come up with sustainable packaging. So as I mentioned, one of our offerings is Granta, which is a library tool that has over 1,000 materials that you can use to figure out what materials you should use. So that's what Mars is using simulation for, as well as different other aspects for their manufacturing processes. But as one of them said, manufacturing tends to be hard and expensive, and you just can't come and change things. So simulation does help them to be able to make some of those decisions and make them in a way that saves them not only money and time, but any changes they make, they're actually sure that they'll be able to optimize their processes and not take away from that. So that's one of the applications that simulations can have. So I'm going to show you another one. So this is racing. So for anyone interested in racing cars, you can actually use simulation for that. So let's see here what Porsche uses simulation for. Again, let me know if you can hear the audio or not.
Motorsport is a part of our DNA and always.
Is the audio here? Can you hear the audio? I just want to confirm as you go. Someone unmute, let me know.
Yes, ma'am, your voice is audible now.
Okay, good.
Played a significant role in the history of Porsche. Formula E is the first series really on a highly professional level, and it doesn't only look at the electrification, it's about efficiency, it's about sustainability. We have the same challenges as another race series. You want to finish first. That's still the same. It's about performance. It's about getting every little bit and piece right. If you have an efficient car, if you manage to be efficient throughout the race, you will win the race. To do quick lap times with the smallest amount of energy. I think that's the special challenge about the Formula E. We've chosen ANSYS because it's a global partner. So they get everything to support our team, to support the engineers, to develop the most efficient powertrain, and therefore to be successful in the series we are racing. That's what it is about, that's our goal, and therefore we clearly choose the right partner. ANSYS is helping us to win by providing the technology, by providing tools and the skills of the people working with us. They give a lot of input to the methodology, how we approach things. Especially in Formula E, you are very much restricted in testing time. So therefore, it's really important that you do most of the development work with simulation. ANSYS provides all the simulation modules, But at the same time, we are improving to simulate and optimize the entire system. You have to do a lot of simulation because you can't go testing. And that is really the benefit they bring to the team. They help us a lot to do in the simulation before we put the car together, before we develop the parts, before we hit the track. That is really the big benefit. And it's absolutely necessary in this series, because if you don't have this very early stage simulations, you won't be able to be competitive. No way. This is also the benefit that ANSYS brings to the road cars, because everything that we learn, everything that we achieve, will be exchanged with our colleagues. Simulation will be more and more important in the future. To me, that's absolutely clear. It's getting more and more complex. So therefore, we need simulation. We really have to try and do as much in the virtual world, in the virtual development, as we can. And that's exactly the benefit that this partnership between Porsche and ANSYS is about.
So from Porsche, you can see what they're trying to do is motorsport racing tends to be expensive. So as much as the cars look small, they're really expensive to develop. So the question for them is, how can they save costs? How can they optimize their designs? And how can they do everything possible to make sure that they're always ahead of the curve and they're able to win against their competitors, because that's how they make their money. So that's where ANSYS comes in for them. To save on costs and R&D, they do most of their testing virtually before they can actually get on the race track. And that also helps them to know how to optimize everything and to make sure that everything that they're actually manufacturing for the cars helps with the efficiency and the effectiveness of their cars. So that's how simulation helps them in their industry. So I'll show you another application. This is healthcare. I think this is a very interesting one because so far we've spoken about simulation as having a lot of physics, structures, fluids. So how exactly does simulation work in the healthcare industry?
Medtronic is driven by the Medtronic mission, which is to strive without reserve for unsurpassed quality. We help guide surgical procedures with navigation technologies, with surgical robots, as well as ear, nose, and throat therapies. So really 70 conditions all over the body, some very short term, some very long term. Medtronic designs products that have to have very high reliability. We also design a wide variety of products. We have to develop different materials, different use condition challenges for us. Simulation has essentially become a requirement for us. We have to anticipate such a wide variety of clinical conditions. There's no practical way to do that ahead of time without actually using simulation. ANSYS is, I think, the perfect partner for us because they continue to grow, to acquire new technologies, and they help us bring technologies that are developed for other industries and other products into the medical device space, which is a huge asset for us. It's almost unthinkable in terms of how we would move forward at today's pace with expectations we have around our product cycle times if we didn't have the opportunity to do this in the simulation environment. I think over time, simulation will become a standard for Medtronic as well as the industry as far as how we actually evaluate our products. We do have products we've looked at historically where we can confidently estimate that simulation has saved us years of development costs or tens of millions of dollars of expense based on the alternatives we had to get those answers. I firmly believe that the work we're doing with simulation modeling with ANSYS is helping us get there.
Okay, so for healthcare, same thing. They're trying to figure out how to come up with solutions for saving time and saving money. So a quick example I can even give is we actually had a high school students in the States who developed prosthetics using ANSYS simulation. So they were developing prosthetics for the veteran soldiers who go back to war and come back without limbs. So how they use simulation was did the design for the prosthetics, then analyze how much pressure would be on this, what materials can I use to optimize this, how can I custom make this for a specific individual. So simulation actually is important in healthcare as well. We've had Some doctors as well use simulation to develop stealth. So like when someone has clogged arteries, they put in a stealth to open the arteries. So we've had doctors use ANSYS simulation to design that and then optimize it so that they can use sustainable materials, and then the design as well tends to be durable. So simulation does have an application in healthcare as well. So next one would be computing. NVIDIA, I'm guessing we all know who is NVIDIA at this point in time. If you're not, they develop almost all the CPUs in the world, or the GPUs. So if you're doing anything high computing, you'll definitely need NVIDIA GPUs. So how do NVIDIA use simulation in their applications? So the goal with this, if you have not yet gotten it, is to show you the different industries where simulation can be applicable and to help you dream big more than probably what you already knew. So if you are at all picking up a simulation skill, there are so many application areas that this can be used in. So yeah, let's hear about NVIDIA.
NVIDIA makes the most advanced computers in the world. Our computers are used for artificial intelligence, for physics simulation, for video games, of course. All of our customers are trying to discover their iPhone moment, to reinvent themselves, to revolutionize their industry, to become software defined. Our partnership with ANSYS solves problems for our customers neither one of us could do alone, and bring solutions to customers that is impossible otherwise. We're at a point now where we're about to simulate at 1,000,000 times higher performance than something we were able to do 10 years ago. 1,000,000 times. And so our collaboration enables a new frontier. ANSYS and ourselves are pioneering this future in digital twins, which is really a simple way of saying the next phase, the next wave of artificial intelligence when robotics makes possible. Imagine every single product in the world with a digital twin that's running alongside it all the time. 1 billion cars, tens of millions of factories and plants and warehouses, fleets of robots all over the place, all have digital twins. And these digital twins allow the engineers to improve the artificial intelligence, improve the software, maintain the fleet, improve its throughput and capability and reliability for as long as the products live. That's completely transformative for our customers. We couldn't do it ourselves. ANSYS, together with us, can really solve the problems for our customers.
Okay, so NVIDIA, again, high computing giant there. So they mentioned digital twins. So digital twin is also one of our offerings. And as he tried to allude to that, the idea for digital twins is how can you model real world situations and then test them in parallel to what is happening real time. So like, for example, if you're trying to build a model city and you're trying to figure out where do we set up the different telephone boosters, where do we set up the Wi-Fi transmitters, where do we set up, how will the autonomous cars be communicating with the different devices? You can do a model town of that in digital twin, and then you can set up the physical one and then simulate what will happen and then see if that's what's actually playing out in the real world. So really strong stuff that's going to be happening in simulation, and it's really, really exciting to see what the future holds for that. So next case, I think I have 2 more use cases. I have aerospace and then I have space, and then we're done with the use cases. So let's see what they do in aerospace.
Embraer is a world leader in aviation and bringing new, innovating products to market.
Every area where we compete, we try to offer the best and more competitive products.
We are working on autonomous flight here at Embraer, and we do believe this is a marathon, it's not a sprint, and we do need the best partners along this run to build it with us. Autonomy is not something that will just happen. We need to offer something that is not equal, but actually better in terms of safety and efficiency. Partnering with ANSYS is really critical for us in the sense that helps us accelerate and more than build a product, help us build the process that will ensure we get to the safety levels we want. ANSYS has a very interesting and very powerful approach with physics-based simulation. And for autonomy, we are exploring something new for our products, right? They now see the environment, they now see the world.
Without simulation, definitely we would take more time to develop new products, more sustainable products. And even worse, I do believe that we wouldn't be able to develop the optimized product for the future. Simulation and virtual testing is key for us in terms of offering for the market the right product in the right timing.
We definitely see simulation increasing in usage as well as relevance to build the processes that will allow us to be efficient and effective at the end of the day. A relevant point is for Embraer to always be on the edge of these technologies, not only because of everything we already talked about, efficiency and reaching really the point in where we have great products, but also to be able to attract new talent. Young engineers are trained in universities using software, using simulation.
I do believe the partnership we have with ANSYS, a long-time relationship, is very strong. We're doing a good job together. And for the future, I see even stronger relationship with ANSYS and the tools provided by ANSYS and the products that we can provide to the world.
Okay, so Embraer, what they're trying to do is create autonomous planes, and they basically use simulation to not only design their planes, but they also use simulation for virtual testing. So something else they might not have mentioned is we actually have a product called Skate, and what Skate does is for you to be able to fly or put out any flight tool, like planes, drones, or anything, they need to meet some regulatory standards. And with that comes with testing, ensuring that the cybersecurity is okay, ensuring that the code used for the autonomous running is okay. So we actually have customers who use Skate to autonomously write their code, no human interface. And by the time that code gets to the certification, it's actually fully certified. So not only do our products help with simulating and virtual testing, our customers also use that to make sure that they're actually in accordance with the industry regulations and the likes. So I'm going to play the last use case for this, which is Pace.
We do space capsule. They bring basically cargo up to station and cargo down. It will be the first time in Europe that we'll have a capsule that can be reused. Our mission is to make space exploration accessible to anyone. So we want to make it affordable, be the cheapest in the market. We want to make it sustainable. We are the first in the world to fly with clean propellant. And we want to make it cooperative.
I get to do what I love, which is basically building rocket engines. This is where I want to be, this is what I love to do. I like to see myself as a problem solver. That is what engineering should be, help society, trying to advance human knowledge.
What is super important is, of course, the engines. You need to be able to fly to station. The second technology is the re-entry, right? We need to come back in the atmosphere. So it's about guidance, making sure that we can control the capsule perfectly. It's also about thermal protection. We don't want to burn. And then there is the docking technology. We want to go and dock with the capsule. So here again, it's about control, it's about navigation, it's about guidance, it's about sensor suite.
The combustion temperature can be higher than 3000 degrees Celsius. So we have very high pressure loads, very high thermal loads. So we want the thrust to be as good as we want. We want the efficiency to be very high. We are sending stuff to space. We want it to be as light as possible to make it affordable. So combining all of these factors can be quite challenging.
Propulsion is number one problem. And the second challenge is more on the re-entry side. We need to make sure we guide properly the vehicle. And the third one, as I was mentioning, is really the docking.
All of these things are very complex to model, and not all of the softwares can do it and can do it well. And ANSYS does all of this in just one software that is easy to use and that is also very accurate, which is exactly what we are looking for.
This is super important to be able to simulate. Every time you test, again, it costs a lot of money. So we can simulate. This gives you a first understanding what the results are going to be. Then you test, you calibrate your model, then you simulate again, and then the more you test, the more the simulation becomes accurate, and then the less you then spend money on testing. And this is for us very useful. It enables us actually to modelize our propulsion system, especially the fluidics inside the propulsion. And the way we work is that we model, we test, we model, we test, we model, we test. Very iterative, fast approach, so that we can improve very, very fast our model based on the results of the reality.
The exploration company is a very fast-growing startup. We will need more licenses, we will need to do more simulations, we need to develop more hardware, and all of this requires
software and simulation tools. And this is where ANSYS can come in, supply all of our needs, and together we can grow and develop innovative and affordable space capsules.
We've saved a lot of time in the way we can increase the efficiency and the accuracy of our models. So that has been quite efficient.
But it's really impressive to see how, let's say, a big company like you is partnering with startups.
Your listening skills about the feedback that we can give to you, that's also highly appreciated.
Okay, so the exploration company is trying to develop rocket capsules, and they're basically using our software to design their rocket engines, figure out what materials they can use. As I said, it's a startup, but using our products, they're able to do way so much. So I hope with those examples, we now have an idea of the different industries, or a few of the different industries where simulation can be applied, and how you as students looking to pick up simulation, where your skills can be needed for that. So I just wanted to end this with a couple of tips as you continue or start with your learning. This is building up to the end of my presentation. I know I've taken a bit of time, but we are heading to the end, so I'll be done in the next few minutes. So first tips, get the basics right. With this, understand your simulation foundation. So what is simulation? What are the different steps that are needed for you to be able to do simulation? Why is it helpful? What tools do you need to use? Choose the right software. Simulation also involves a lot of physics and mathematics, so it's very important for you to take time to brush up on the fundamentals of that, because simulation is similar to computing, garbage in, garbage out. So if you're providing the software with inaccurate data or inaccurate assumptions, or you're not sure what you're solving for, you won't be able to get the accurate results. So it's very important for you to take time to also brush up on the fundamentals for the math and your physics. Next thing is, once you get your basics right, next thing is to level up your skills. So that may include taking online courses, making sure you practice by learning, by doing, and then keep on building on your learning. So for example, for like online classes, you can find YouTube videos. I'll also share a link where we have free courses that you can use. And then learning by doing means you don't just watch the courses, you actually take time to practice what they are doing, because simulation does tend to be a bit hard and challenging as you're starting out. But the good thing with this is that it's a skill that can be developed over time. So probably your first simulation will be hard. You might not understand what you're doing, but the more you keep on actually practicing with the tools, whichever tools you use to pick up, continue practicing, continue learning. And by learning here, we also mean read on the research that is currently being done on simulation. So use your online courses, but also follow up on the research. Figure out what the industry is looking at, and then see if you can do projects in that area. That also helps you in terms of marketing your skills. So level up your skills, keep learning, and always keep on sharing what you're doing. And then lastly, seek continuous growth. So join communities where you can learn with others, seek mentorship, look for people who can guide you. Simulation is a large field, as you probably have seen from the application. You can can use it for structures, you can use it in healthcare, you can use it for space, you can use it for racing, different industries. So depending on where you want your focus to be, it always helps to seek mentorship so that someone who is ahead of you can guide you on this is what you should do, this is what you should not focus on. Probably the materials you're looking at are focusing on this technology. We are now in 2024, probably that is obsolete. So someone who can guide you and take you through the ropes. And lastly, always stay curious and persistent. Keep learning, stay foolish, stay hungry. That's Steve Jobs. Always be keen to know more and to always ask and to seek to grow in your knowledge. So know your basics, grow your skills, and always seek continuous growth. And I think that's it. I'm happy to answer any questions you might have. Thank you so much for taking the time to listen to my presentation, and I really hope that has been helpful. So I'm going to stop sharing my screen so that I can come back to Meet and I can see if I have anyone with any questions. So thank you so much. Anyone with questions? Let me check if I missed anything in the chat. Can I share the PDF? Yes, I'll send that to Naresh and he can share with you. I'm so sorry for the issue with sharing early on. Anga, yes, you can contact me via email. Let me drop that in the chat. And if you have any other questions, feel free to raise your hand and I can take them. I'll also share links to free courses as well as the free downloads that we have for software, and you can check those out. So yeah, let me know if anyone has questions. Free to answer them. Okay, so Naresh, I can't see any questions. Do you want to take over?
Yes, ma'am. From my point, I can ask some questions, ma'am.
Okay, please.
My first question is, people generally ask me that how can they learn about ANSYS simulation? How can they know a well-versed detailing of ANSYS, ma'am? Could you explain in brief?
Yes, so you can always go to our website, ansys.com. I've also shared 2 links in the chat. So one is for our free courses, and the second link is to our free student downloads, which you can download and be able to play around with the software. So, and alternatively, if you have any specific questions, please feel free to email me and I'll answer that. So yeah, I'd say those are the 3 ways you can learn about what we do as ANSYS. You can check out our website, ansys.com. You can check out the free courses and the free student download versions I've shared, or you can email me if you have any more specific questions. Hope that has answered that, Naresh.
Yes, ma'am, that's clear, ma'am. Can you put your LinkedIn ID on the chat, ma'am, so people can follow you?
Yes, I can do that. So just a minute. Okay, I'll put that in the chat as well.
Yes, ma'am.
Okay. Okay, that's my LinkedIn. Feel free to connect, email me, text me on LinkedIn, tag me with any questions you might have. I'll be happy to help and assist. Any other question, Naresh? Or anyone else from the team?
No, that's all, ma'am.
I'll share the PDF version of the presentation with you. Naresh, so that people can take time to go through a bit more. And thank you so much for having me. I hope you are able to pick up a lesson or two. Can we
We had a
start?
question, ma'am.
Can you start with the scratch from the links you provided, ma'am? Yes. So our courses are really easy to follow and understand. If you need a more curated version, so let's say you're really not sure where to start from, let me know and I can see how to. Actually, let me share my screen. It's easier if I do this. So let me open this up. Let me just share my screen and give you an overview of the learning courses platform. Might help someone. So share. So if you go to our courses website, this is how it looks. So it has a lot of free courses that you can take, right? So this can be confusing for you if you're actually starting from scratch and you don't know where to start. So what I always advise people is it tends to be better if you come and take a learning track. So we have we have divided the learning track into different things. So if you're interested in CFD, you can take the fluids. You can click on fluids. If you're interested in structures, you can do that. So let's say, for example, people here are interested in fluids because it's a CFD group. So if you click on fluids, you'll see the different learning tracks that we have. So you have one on physics of turbulence, viscous fluid flow, multi-phase flow. So this is more of like physics courses to help you up, get started and freshen up on your knowledge, fundamentals of theoretical, applied thermodynamics, radiation heat transfer, etc., etc. So learning tracks tend to be helpful because a learning track is a combination of different courses. So let's say this learning path for getting started with ANSYS Fluent. So if you click on it, I'm waiting for it to load. So if you click on it, this learning track has a collection of courses that will help you get started with Fluent. This is beyond the basics. So there's a basics learning path. Let's find that one. And of course, it brought an error. Okay, let's just use this for me to explain what I'm explaining. So under this learning path, it has 3 courses that you can take. So the courses are normally in the learning parts, the courses are organized in terms of difficulty. So this is the easiest, then you advance on that, then you advance on that. So the learning parts do help with a more structured approach in your learning in case you just come to the free courses and you're lost on where to start. So I'd advise you to look at the learning path. So I really hope that's helpful. Always feel free to reach out if you have any questions. So yes. Did I miss anything in the chat? Yes. So I hope I've answered that for you, Shan. Okay, you're welcome. Any other question?
I think that's all, ma'am.
Okay. Thank you so much once again. Thank you, Naresh, for giving me the opportunity to speak to your community. I really hope that this was valuable to everyone. Hoping to see all the amazing things you all do down the line.
Thank you, ma'am. I want to especially give a mention about you, ma'am. You are such a great human being for accepting our invitation to speak about our community and for delivering a good speech among the beginners about the simulation.
Thank you. Happy to have been able to do this. Thank you for the opportunity. Let me know if you need something else. Always happy to help you get started with your learning. Once again, thank you.
Thank you, ma'am.
Okay, can we close the call?
Yes, ma'am. We can wind up the session, ma'am. Once again,
Awesome, awesome. Please go ahead, Naresh. Okay.
we can
I'm
wind
not
up
sure
this.
what happened. Okay, Naresh. Okay. Thank you, guys. Naresh, you want to close us off?
Yes, ma'am. We can close the meet, ma'am.
Thank you, guys. Bye. Shout out to Ogueno, Charles, Eunice, the few people I know. Bye, guys. Thank you. Let's connect. Bye.